This is a nvram.weebly.com MPU, which I like the construction of. There's surface mount chips used in a number of locations other than where U20, which is, as we know, frequently blown out by high voltage shorts to the switch columns. But on this board, it had a problem with row 8 ground short. Now that usually points to the LM339. So I have installed a socket and installed a working LM339. And what I like about this board is if you have a surface mount part failure, you can use chip quick or whatever technique you prefer to remove the surface mount part, and then the pads are there already for a through hole component. So that's exactly what I did here. I took the 339 that was here out with some chip quick and cleaned up the pads to make sure there weren't any shorts between them, installed the socket in a new part. But here's the new kind of thing that you got to watch out for, I think, with surface mount parts, because I still have a problem with a ground short on row 8, and I'm pretty sure what the problem is that there's a 1.2K pull-up resistor. This is the row 7 pull-up resistor, and you can see that's easily making, and I'm touching the actual surface mount part versus the solder pad that it's supposed to be attached to. Now here's row 8, and there's no conductivity or connectivity to the actual part. But if I touch the pad, yes, we have it. So after having gone through replacing the 339 and the header, because there didn't seem to be enough voltage on this pin, and these are things that I would have done with a through hole board, what I've learned through this repair is that I need to suspect the solder joints on some of these surface mount parts. So I'm going to put a little flux on the top of this 1.2K resistor. In fact, this will be another good test. I haven't done this yet. But from this pad, well, let's do a control point first. From this pad to this pad, I hit 0.2 ohms. Nah, I'm sorry, I was doing that wrong. Let's see, it's a 12 volt pull up. So let's see, 280K. Let's see. All right, let's see what I get on this part. Well, I'm not sure that proved anything. Let me correct this joint and I'll be right back. Good morning, happy Friday morning to everybody. A Party Zone MPU board, and right now you're going to get the check fuses F115 and 16 because it's not seeing some switches that it thinks it should be seeing, and that makes total sense since it's on my bench. The solenoid that is turned on here is number 24, so let's check that when I go into test. Well, what I've done to these boards is first, this dirty DMD controller. I've replaced the 47K resistors and the filter input cap and the headers. I did not replace these dual row headers, or that one up there, but the headers on the bottom, and I think the two N55, 51s on this board were shorted also. So I've made it all 100% operational again. The soundboard did something that I've never seen before. The ROMs weren't inserted all the way, and or well, the two of them weren't, the two lower ones. So I put those in, but the sound was still scratchy. So removing U18 and then replacing it cleared up all that scratchy sound. I would have never guessed that would happen. The blue caps are all new. These two radial caps in the center, the black ones, those are new. The 100 microfarads new over here. The big fat tantalum there is new, and the 22 microfarad is new. The two 4700 microfarad are new, and I'm going to put one of my new heat sink protective fish paper things on top of there. So this board is ready to go also. Oh, I did replace all the tantalum caps that have a tendency of blowing. And no, this was not the board that had a hole underneath one of the tantalum caps. It came with this Weebly MPU board, which I probably rolled in the footage showing where one of these 1.2K resistors was not soldered to the board and making with its solder pad, and that was causing a column short row 8. The driver board, I did my regular updates to driver boards. All the power headers, C5, C4, C2. There's another power header up here. The GI headers, this power header, and I think, I added a 1N5401 diode to the bottom of this sand resistor, and that prevents C11, which somebody else has changed for reasons unknown, but it prevents C11 from blowing up if you connect, for instance, the playfield coil power connector down here inadvertently. I don't think many people do that, but when they do, it's rather catastrophic to C11. So it's running sound or ROM level 1. Let's get into all the tests. We're going to test all the functions using my spiffy dumbass test stuff. Just to review, this is the test panel for all the switches, and I can test use the direct switches and coin drop switches. And this is a pre-Fliptronics game also. Yeah, definitely a pre-Fliptronics game. So let's back out of this and get to the next test, which is solenoid test. And we'll make it run. Run, solenoid test, run. I got a million of them. Solenoid 24 appears to be locked on. I got to figure out why that is. That may be normal for Party Zone, maybe not, but I will consult the manual and see about that. I'm going to do GI test, and all these strings are working. Outstanding. I'll come back to the sound and music, but here's lamps and flashers at the same time. Interesting that solenoid 24 appears to be a flasher because it's being driven in the lamps and flashers section, and the lamp matrix is working perfectly. So let's come back to the sound and let's see what Captain Bizarre. I could make out most of those, but I do not know what chicken feet was. So that is all the tests for this entire board set, and I'm going to investigate the solenoid 24, but let's see what happens when I go out of test. Oh, I see. This is the direction and solenoid enable for the motor for the device on the playfield, which I get Party Zone and Dr. Dude all mixed up all the time, but if Party Zone has got Captain Bizarre, that's what this is for. Thank you so much for sending it.